All right, my friends. What do we got? 11. Let's get letter K out. See how we did. Letter K.
It's one of my favorite trips. I get so tired though because I wake up at 5:30 Denver time, which is 3:30 Denver time, and so I 5:30 4 in the afternoon. I'm dead.
Questions on K. K. Whoa. 6 on number K. Okay. All right, number 6.
That's what he said. High school.
Okay, it says, settle down, please. For each rational function, identify the equation of the slant asymptote as the equation of the line. Show your division. All right. So we definitely know it has a slant asymptote or an behavior or an oblique asymptote. Yes?
Yeah.
Why is that?
Because the top's bigger than the bottom.
Yeah, the larger degree on top. So, long division on it.
We just did the even.
Yeah. All right, so multiply by x. That becomes x squared. When we subtract, that's 0. Bring down the 3x. What do you have to multiply by 3 or by x to get the 3x? 3. Subtract. Nothing. Bring down the -2. What do I have to multiply by x to get to -2? You don't. That's your remainder. Ignore it. So y equals x plus 3 is my n behavior linear asymptote.
So you don't really have to keep going after you get.
Nope.
Okay.
Yeah.
Is that number going to mean anything later on?
No.
Okay.
Not for these. What else? 8. Number 8.
Oh, no.
Okay. So, vertical asymptote. We have it at x equals -2. No, horizontal asymptote's not listed, but we use the official math term nope. And then OA, the oblique asymptote, is you just have to do the long division. So you go x plus 2. And then change the order of this when you put it in. We good?
Yeah.
All right, too much chatting. So, what do I have to multiply times x to get to -x squared? -x. So I get -x squared minus 2x. And then we have a gap here, right?
Yeah.
So, one spot that some errors are taking place. See where I have that subtraction right there? So the best thing to do when you have that, and it's the big error that a lot of people make, is because that subtraction takes place, do this. Distribute, so then make that a positive, that becomes positive, that becomes positive. Is that okay?
Yeah.
Hush over there. So that becomes 0. Now, when I start bringing things down, can I combine 1 and 2x together? No. So then I get a 2x down here, it's a positive 2x, and then plus 1. Is that okay?
Yeah.
What do I multiply times x to get to 2x? Yeah, just 2. So 2 times x is 2x. 2 times 2 is 4. And we're going to subtract. And again, my friends, change this to positive, negative, and negative. That gives me a 0 there. That gives me a -3. Ignore the -3. So my slant asymptote is -x plus 2. Let's see. X-intercepts. X-intercepts, they do indeed take place. That's the difference of 2 squares. That becomes 1 plus x 1 minus x. And so I get x equals 1, x equals -1. So there's my x-intercepts. And y-intercept, plug in 0 for x. So I get 1 over 2. Then I'm pretty set with the domain. We can maybe do the domain last, so if I just graph this. Let's graph my roots. So I have +1, -1. Agreed? 0, half. Is that okay so far? And then let's put in vertical asymptote at -2. That okay? And then my slant asymptote, we'll make it yellow. My slant asymptote is at +2. I'm going to go down 1, left 1, because we know how to graph lines, right? All right, so here's my graph. This comes up and does this. And then over here, this would take place up here like that somehow. That's what we're looking at. Done. What else did you see? What else? Yeah.
So, how many points is the non-calculator part?
255,000.
All right, and then the calculator?
310,000.
Yeah.
Which one?
10.
10?
That's helpful.
You know me, I don't look that far in advance. What I do is I figure out how many you miss, and that's what I make it worth.
Perfect.
All right, number 10. Okay, let's go ahead and just factor the top out first. So I forgot to do that on the last one, but we did it when we found the roots. This one does not have a hole, does it?
No.
Nope. So no hole on it. So let's take a look. Vertical asymptotes is x equals 2. That's when the denominator is equal to 0. Horizontal asymptote, that's a nope. An oblique asymptote, right here, right there.
Okay.
So long division. What do you have to multiply times x to get x squared? That would be x. X times x is x squared. X times, that's minus 2x. Remember, we're subtracting both of those. So make sure, I honestly think this is the best way to do it. You make that plus, make that negative, make that plus. So then I get negative x minus 4. What do you have to multiply times x to get to negative x? Negative 1. So that gives me 0. So make that plus, plus, and minus. Ignore the negative 6 remainder. So my oblique asymptote is y equals x minus 1. What else do we need to know? X-intercepts. X-intercepts will be at 4, 0. So what you're doing is just looking here. And negative 1, 0. Y-intercept. Plug 0 in. So I'm going to get negative 4 over 2. Negative 4 over negative 2, so it's 2. And we'll take care of the domain later. Let's just graph it. All right, points that I know. I have 4, 0. I have negative 1, 0. I have 0, 2. Okay, so that's taken care of. Vertical asymptote is at x equals 2. Okay. And then oblique asymptote, so negative 1 is here. I'm going to go up 1, right 1. There's that. You can kind of see where your graph is going to go, right? So it's going to do this. Looks like that. Cool. And then the domain goes from negative infinity to 2, 2 to infinity. Now I heard a question yesterday, and it's worth hitting. The end behavior, which is the oblique or the slant asymptote, does not affect your domain at all. But could you see how someone might throw it in there that it could? Yeah. So the end behavior. So it's only your vertical asymptotes that vertical asymptotes and holes that mess with your domain. Cool? All right. Make sure your names are on those. Pass those on forward, please. So tomorrow we have a quiz. Okay? Now,
When do you want us to do that cap stuff by?
soon. Sooner the better.
Until I get like a definitive date, I will not.
When I yesterday, I just didn't have it.
Soon.
I tried it. Issued the marquee not.
Oh, will you just write me a note, a big old note on the top of your page?
Yeah, I was turning it back in.
Okay. And there you are. On your fancy dancing. All right. So, on tomorrow's quiz. Originally I felt that on the multiple choice we could use a calculator. I think after today's review, there's no reason to use a calculator on it. After looking at it, it's like it won't even help you.
Can it be optional?
No. So after today's review, I mean, we have spent enough time on figuring out asymptotes that you should have them down. Okay? Honestly, if you were to do the 15 questions multiple choice, and you get the one kid going, I'm going to graph every one of these. Well, there's 15 questions. Each question has 4 answers. If you tried to graph all 4 answers, there's not enough time between now and the end of the school year for you to graph everything to try and figure it out. Plus, you can't see holes on your graphing, so that's not going to help you. You have to know the rule for a hole. But after today's review, I think if you maybe took a period or two and you were maybe reading a book or using your phone and you missed something, I think I'm going to fill in everything. So you can use a scientific calculator on the whole thing or a 4 function. No, you can't use your phone.
What about the ones where you have the thing and dips down like this and it goes like this?
You're not going to see it.
Okay.
I'm giving you simple graphs.
Oh, okay. None of that funky stuff. Where
No
it's like
funky.
The little hill in the middle.
No little hill in the middle.
I better sit in the front today.
All right, so we won't use, you can use a scientific calculator on the whole thing. I'll give one the cupcake over here.
Well, now that you don't throw a whole wrench in my time, just to start.
You want to make it?
Just one. Just one.
Makes lots.
Yeah.
Lots of now. No, really lots of.
How do you find it?
You can ask her like in the review, are you?
All right. So after today, you will have a good amount of study guide that will help you tremendously tomorrow. Okay, so let's go through and answer the questions we know. Did you get one, Lee? Who's not passing back? Everyone have notes now? Fiona, do you have notes? Good. All right. So what part of the function do you consider when you're looking at the vertical asymptote? What x? Yeah, the denominator.
To see what happens to make it 0.
Oh my gosh. Denominator set equal to 0. What happens if we had a denominator of like x squared plus 4? That won't factor. And if you try to solve it, you'd get plus or minus 2i. Do you have a vertical asymptote?
No.
No. So if it doesn't factor, and if you were to solve it, if it does not produce real numbers, okay, yes, you could have square root of 2, but I'm not going to give you something like that. But if you had something that was like x squared equals negative 4, take the square root of both sides, so you get x equals plus or minus 2i, there is no vertical asymptote. Okay? Does a whole supersede a vertical asymptote?
What do you mean?
Like, is a whole more important than a vertical asymptote? Would you put?
No.
No, you use a whole. The whole exists, and the vertical asymptote at that point wouldn't exist for that number. So if your denominator factored to say like x plus 2 and x minus 2, and let's say x minus 2's canceled out, being the x minus 2's cancel out at 2 comma something, you're going to have a whole. That's not going to have an asymptote. You're still going to have a vertical asymptote because the x plus 2, that would be x equals negative 2 for an answer. So I think we have a slide on that, so we'll cover that in a little more detail. When will a rational function have 2 vertical asymptotes? Yeah. So if you had say some denominator that was this,
X squared.
and then that factors down to x plus 3, x plus 4, and that does not cancel with anything in the numerator, this is going to give you vertical asymptotes at x equals negative 3 and x equals negative 4. That's when you're going to have 2. Okay? If no vertical asymptote takes place, if you had something like this, okay? So if you solved it and it came out to an imaginary, and we already talked about it, but if you turned out that you had an unsolvable, or if it solves to give you imaginary roots, and I mean that could include if you have the quadratic formula, and you do the quadratic formula, and underneath the square root is negative once you do the arithmetic. Once you do b squared minus 4ac, that's called the discriminant. So once b squared minus 4ac, once you do that math, if it's negative, you don't have a vertical asymptote. Okay, but yes, you can have 2 vertical asymptotes. The main thing, starting any of these problems, the very first step on doing any of these problems, is you have to factor. You have to factor it. Okay, how do you find the x-intercepts or roots?
Substitute 0 in for y.
Yeah, so use the numerator
It's what makes the numerator 0.
equal to 0, right? If things canceled out because you have a hole there, okay, you wouldn't have an x-intercept at that particular spot. So if your numerator came out to be like x squared minus 4, and then it does whatever down here, that gives you x plus 2, x minus 2, and that gives you negative 2 comma 0 and 2 comma 0. Okay? So if nothing canceled in it, you're just looking at the numerator. So x-intercepts are for the numerator. Vertical asymptotes are for the denominator. How do you find the y-intercept? Oh, that's the easiest one. Plug 0 for x. Okay? So you can plug 0 in whether you reduced it or not. You can go into the original or you can go into your reduced version. It's still going to give you that. So on this you'd have 0 comma something. Okay? And then let's see what this last thing says. What do you consider when determining the horizontal asymptote?
Is it bigger on top?
What is bigger on top?
The
exponent on top. So the degree, which is the exponent. on top is larger. If you have a horizontal asymptote, or if you have a slant asymptote, do you have a horizontal?
No.
No. If you have a horizontal, do you have a slant? No. Okay? So you either have a horizontal asymptote or you have a slant asymptote, or oblique, or an end behavior, whatever term we want to use. Does that make sense? All right. When will a rational function have a hole in the graph?
When they cancel.
When you can cancel. So if you had something like this, let's say it's already factored. This right here will produce the hole, and this would produce a hole at -1, comma, and then you take -1 and plug it back in here and here. So you get -1 plus 2. That's 1. And you get -1 minus 3, which is negative.
-1/4.
So -1/4. That's where the hole would exist. You can also have a hole in this scenario. Let's say we had 5x over x plus 2, x plus 3. Because I have an x on top, this would create a hole at x equals 0. Okay? And then let's put like a plus 2 up there. Okay, so that would give you a hole there. Or actually, let's not worry about that. This will work. So if I have a hole at that means that my remaining equation is this. 3. So then you plug 0 back in. You're like, okay, 0 plus 2. Okay, so that's 2. 0 plus 3 is 3. So you'd have a hole at 0, comma 5 over 6. So if you try and plug in your information to the original problem for your hole, if it happened at 0, or if your hole happened anywhere, it's going to create 0 over 0. Okay, so go into your factored thing. When will the graph have a slant asymptote?
When you have no horizontal.
Yeah. So no horizontal.
When the top is bigger than the bottom.
So no horizontal. And then degree / exponent on top is larger.
You going to the lights out walk, Stirrup?
No, they just had that here.
Seems dangerous, dude. They start walking at
8:30. No, who hangs out around here at 8:30? You don't want to be here at 8:30.
That creek?
Yeah.
It's
East is the
run
scariest at 8:30.
You're right, you don't want to be in
The worst.
village at 8:30.
Random janitors pop out of random closets at 8:30.
Yeah, the janitors are here.
They literally do it. It's horrifying.
Are we good so far?
Waiting.
Yeah.
So how do you find
Alright, I'm good, thanks.
Good?
No?
Anyone else need more time here?
No, we're fine.
No horizontal.
Alright. So now we get to start graphing. So just by looking at this one, just look at the equation. Is there an end behavior asymptote? Is there a slant asymptote? Is there an oblique asymptote on this one? No. The degree on top is 0. The degree on bottom is 1. So we don't have that. Vertical asymptote will happen at x equals 5. Yes?
Yeah.
Okay.
Hey man, it's all
Horizontal asymptote, yes or no?
Yes.
no.
Oh, this is the trick one. Why is it a trick one?
It's
There's
0.
a 4.
What?
Plus 4.
It's at 4. So because the horizontal asymptote's looking at this one now, because the whole thing isn't a fraction, you have to realize, oh, at that positive 4, I have that asymptote.
Nice.
Okay? Ooh, that's kind of a trick. So let's keep note of that. So
What is that?
Oh, that means when you.
This one is that thing.
that was in the very beginning of the unit. Okay?
Less than absent.
So horizontal asymptote is at y equals 4. The only time that happens is if you have a constant that you're adding to your fraction, a constant being a number. Y-intercepts and roots. So if I plug 0 in, I get 3 over negative 3/5 plus 4. So good thing we have a calculator that we're going to use, the scientific calculator. So 4 subtract 3/5 is 3 and 2/5. Bless you. Thank you. Okay, so y-intercepts at 3 and 2/5. So somewhere in there. Roots.
Plug in 0 for y.
Plug in 0 for y.
You
Okay.
have to put 4 on the other side.
So yeah, there you go. So if I plug 0 in for y, I get this plus 4. Subtract 4. So this one's a little tricky because this is from the beginning. So then I get negative 4x plus 20 equals 3. Subtract 20. So x equals 17 over 4. So 17 over 4 is like a little bit bigger than 4. So we have, there's my only root. So my root is at 17/4, comma 0.
You just times by x minus 5.
Yeah, so I subtracted 4, then I multiply both sides. So I have this, and I have this. Done. Okay? Folks, you'll see almost that exact problem tomorrow. There's only one, and this will be on the graphing part.
Oh, what about the domain?
Is that for domain on this one?
No.
Is the graphing part the one with the multiple choice?
No. So if they did ask for the domain, we say domain is negative infinity to 5 and 5 to infinity. I know this one didn't ask for it, but just in case. Yeah.
How do you know which way the arrows go?
Because we found these points. So they're always vertical angles from each other. Ooh, there's a geometry term. Remember vertical angles?
Geometry.
Yeah.
Was that last week, Sam?
Nah, that was like a few months ago. Like 4 months ago, maybe.
All right.
With
Good.
the circles.
Can I move on?
Is it if there's a negative
Good,
x,
good.
Okay, so you just find the points and then.
Yep.
Cool beans, dude.
All right. Vertical asymptote, yes or no?
Oh, yes,
Yeah.
sir.
Where at?
5.
Y equals, or x equals 5, right?
Yep.
And the horizontal asymptote is 1.
How do you know?
Because same
Yeah.
on top and
So
bottom.
degree on top, degree on bottom are the same. Lead coefficients are 1. So my horizontal is at y equals 1. So if degree,
Seems like a lot of exceptions in this.
Maybe we're just an exceptional class.
We are, Sam, we are.
Yeah, all do.
does that make sense? So if degree on top and bottom are equal, then y equals whatever the lead coefficient is.
Oh.
So you look at your highest exponent, whatever the number in front of it is, there's a 1 on these.
So even if it was 2x minus 6 over x minus 5, it'd still be y equals 1.
No, if it was 2x on top and 1 on bottom, it'd be y equals 2.
Yeah.
If it was 2 on top and 5 on bottom as the lead, it'd be 2/5.
It's like gonna be the fractions in front of the x's.
Mm-hmm. Y-intercept. Y-intercept.
I'll figure it out tomorrow.
Y-intercept is
Negative
0 6/5.
over negative 5.
Yeah, right. So 0 6/5, which is like here. Roots. So x minus 6 equals 0. So at 6 comma 0 is a root. So because I have that point there and that point there, I know that this is what my graph's going to look like. And if it asks for the domain would go from negative infinity to 5 and from 5 to infinity.
So like, how exact does our graph have to be?
Just kind of close to that.
Okay.
Kind of is the key word. So if you had like something being drawn down here, you're going to miss something. Can I move on?
Yeah.
Woo!
But that's the point.
All right. Vertical asymptote. Ooh, well let's factor both of these first. So this is going to factor to this. Agree?
Oh,
Agree? And then What is it? X minus?
3, X minus 2.
Ooh. We match up with the X minus 3 on top and bottom. What does that mean?
There's a hole.
We got a hole. Okay? Because these match up. I have a hole. Ooh, I have to put, I have a hole. I haven't have a hole. So my hole takes place at 3 comma something. How do I find out the something?
Plug
You
three
plug
in.
it back
Say
in.
X.
Yeah,
Plug
you,
X.
minus 2.
so in order to find this right here, I'm going to plug into here.
So it's going to be 2.
So 2 over
2. So
3 minus 2. So 3 comma 2. So
So
3
you just
comma 2.
ignore the stuff that cancels.
Yeah,
out.
you something cancels out, made the hole, then you plug into the remainder. So
Sure, could you do that again? Like
yeah. So if I cancel out the x minus 3s, I'll wind up with this. X minus 2, right? So then I'm going to take 3 and plug it in here into the x. There's no x on top, so I'm going to get 2 over 3 minus 2, 2 over 1, which is just 2. So 3 comma 2 is my hole.
How do we graph the hole?
All right, so everyone see the hole so far?
Yeah.
Vertical asymptote.
It's 3 and 2.
The hole took over one of them.
So 2.
So the hole,
So it's
this
just
was
2.
the hole. So this is going to be our asymptote. So I'm going to get x equals 2.
That's a little trippy.
Trippy.
That works though. It's chill. It's chill though, so.
We good there?
Yeah.
Horizontal asymptote, the degree on top is just a number on top, so that's x to the 0 on top, right? Because x to the 0 is the same thing as 1. So my degree on top is bigger than my degree on bottom. So my horizontal asymptote, or my degree on top is less than my degree on bottom. My horizontal asymptote is just going to be y equals 0. Okay, we don't look at any leads on that. Okay? So we have a hole, we have a...
How did you do that? I thought it was negative.
So the degree on top is 2x to the first. The degree on bottom is x squared. X to the first is smaller than x to the second, so it's always y equals 0. If the degree on top is less than the degree on bottom.
If the degree on
Uh,
top is
wait,
more,
say that one more time.
Would it never be negative?
like the equal.
Oh yeah. So if your degree on top and degree on bottom are equal, and let's say the coefficients, the numbers in front of them are like -3 over 2, then we'd have -3 halves. Okay. All right. Let's see. Y-intercept
0, 1.
0, and then I plug 0 into the original, so I'd get -6 over 6, which is that right? So y-intercept's here. Agree?
Sure.
Roots. Where do we set equal to 0? Top or bottom?
You said y equals.
Yeah. So you get this, right? Which is x equals 3. So 3 comma 0. So all you do is you just take the top and set it equal to 0 to get the root. Okay, so I get
Just the top.
just the top. So 3 comma 0. Ooh. Ooh. This is one of the goofy ones.
Isn't this on the horizontal then?
It is. That's on that. Yeah, it is. All right. So I would say this graph's going to look something like this. And this one is going to come down, hit the hole, hit that, and then like,
Dang.
not do that. I don't know why I made that little check mark. Something like that. So it like comes up a little bit and follows along above it.
How could there be a point on that?
Yeah, I thought you couldn't hit the.
So every now and then there's something that breaks the rules.
So just ignore them.
Well, so at that point.
Right.
So domain of this one, if we had the domain, we'd say -infinity to this asymptote at 2. Oh shoot, we have a hole, so we're going to go to 2 comma 3. Even though that does exist, we probably want to put it in then 3 to infinity. Honestly, if you had this right here, I think that's like a calculus term. So if you miss it on tomorrow's, you should be fine.
So, tomorrow's test, are we gonna have one?
Yeah, you
where,
might have
like,
some domain
hits
on there.
the horizontal, like a point on the horizontal asymptote.
Do what?
Like, you know how it's like kind of ignoring the rules right here? We can have one that like ignores the rules.
I would say you might see something like that on the multiple choice, and I would not have this answer and negative infinity to 2 and 3 to infinity. I wouldn't have them both there. I'd have one or the other.
But like not on the graphic.
Right.
Okay.
I'm not gonna hit you that kind of rail.
You're not that guy.
So the multiple choice has been pretty easy.
The whole thing's pretty easy. It really is.
How many questions?
27.
19.
The whole test?
15 multiple choice, 4 graphing. All right, last one. Determine the characteristics of the graph. Okay. All right, so vertical. Let's factor each. So the top factors to x plus 3, x plus 4. Yes. The bottom factors to x plus 3 and x minus 2. Is that right?
Yeah.
Uh-oh. What does this mean?
A hole.
Oh.
We have a hole. So the hole is going to take place at -3, comma. How do I figure out the rest of it?
Plug it into x plus 4.
Yeah, so to find this right here, I'm going to plug it into this and this. So I'm going to go -3 plus 4 is 1. -3 minus 2 is -5. So I wind up with -1/5. So -3, -1/5. So it's like somewhere in there, right?
Yes.
Vertical asymptote. So the vertical asymptote is only related to this one. So x equals 2. Okay? You just look at the denominator.
Which one's the numerator?
Top.
No, I'm saying like for what?
X plus 4. Oh, that's for our roots.
For our roots.
So for the multiple choice, is it going to be like, here's a graph, find the vertical, horizontal, and stuff? But it's like,
Super simple. You're going to be like, dude, are you kidding me?
okay.
Yeah. Oh, it's a negative? Thank you.
Man, there's so much negativity going on today.
Oh, there is. Y equals 1. -3, -y5. Right there.
What?
All right. Let's see. X equals 2. Horizontal asymptote. The degree on top is equal to the degree on bottom. So we look at the lead coefficient, which is a 1/1. So horizontal asymptote is at y equals 1. So it's
0 when the numerator is bigger than the denominator.
yep.
Yeah.
It's 0 if the degree on top is less than the degree on bottom. If they're equal, you take the lead coefficients. Y-intercept, I plug 0 in for x. So
it's
12 over -6, so it's -2, so 0, -2, right? And then the roots. So for the root, this is the only one I'm going to look at, right?
Yeah.
So I'm going to get -4, 0. Why don't I look at the other one? Because they're produced a
Nobody
hole.
likes the other ones.
Nobody likes the other one. So -4, 0. So it's here. So we're going to get whoop, and then that. And then if it did ask for the domain, we'd say, hey, the domain goes from -infinity up to the hole. The hole's -3. So then from 3 to the asymptote, and then from 2 to infinity. That's all I have for the review. You have 4 minutes. What else can I help you on? Do you want me to write down all the rules? Yeah.
How did you get the -3 to the whole for that?
Because these matched, right? So you set it equal to 0.
Oh, okay.
So -3. Okay.
God.
Yeah.
Horizontal asymptote.
No horizontal
So
asymptote.
nice.
Where it's like, where it's x squared on top.
Drew, I missed it.
In oblique asymptote.
Dude, oh my god, I'm feeling myself.
You can seriously That's pretty sweet. It's not much you want. Pennies. They are serious.
Yeah.
They're like
Cards get more.
I got a geo big test tomorrow too. I've been studying the last 2 years. It looks like poop season here, but I'm just ready for it.
This one would probably look something like this.
Like do like this.
Yeah, we want the slant, so. Don't worry about PPR.
I didn't have to.
But I didn't have to ask her, which is nice.
Thank you. Thank you.
KKK, right? There's a form.
Do I just get it in the counter? Okay, perfect.
Grocery lists.
And like, what do I have to do?
You fill it out, and I will.